Hello again, and welcome back to A3 Math. Before we get into today's video, what we should know is our probability formula, right? We know this to be our favorable outcomes all over our total outcomes. If this is new to anybody, please go back and watch the video on our introduction to probability. What we will learn today is we will learn how to graphically represent different questions and analyze the data that follows. So let's get right into it. This example, the weights in kilograms of 40 students are shown as followed. So this right here is called raw data. It's called raw data. So what's happening here is each student is weighed and their weight is written down with no rhyme or reason behind it. This is good, but not for analyzing, right? So we're going to want to come up with a graphical representation of the following. So to do so, we're going to start off by having intervals. And now these intervals, they have to be of the same dimension. So in this case, and they have to cover the entire data set. So in this case, we're going to start off by saying 30 to 34. And since they have to cover the entire data set, our next is going to be 35 to 39, 40 to 44, and so on. 49, 50 to 54, 55 to 59, and 60 to 64. If you go through these weights, none of them are going to be below 30, and none of them are going to be over 64. Next, we want to create a tally. So we want to go through each data point and place them in one of the intervals. So let's go ahead and do so. 43, 62, 45, 50. Now I'm just going to restart when I have completed the tally. So the tally is now complete. All I did is I went through each of our data points and I made a mark with the resulting interval, within the resulting interval. So the class mark is simply the middle point of our interval. So the middle of interval. So for the 30 to 34, our class mark is going to be 32, 37, 42, 47, 52, 57, and 62. Literally just the middle point in our weight intervals. Our frequency is just how often or how many tallies we have within each interval. So in this case, 2, 3, 6, 9, 11, 7, and 2. Now it's important to note that our frequency adds up to the total, to our total. In this case, it's 40 students. So the sum of our frequency should equal 40. That's just a good double check. Just in case you've missed one of your points by accident, it's always good to double check. So next, we're going to want to try to graph. And in graphing, we're going to create histograms. We're going to create a histogram. Now, a histogram on your y-axis is going to be your frequency. And your x-axis, well, in this case, it's going to be our weight. And our weight is in kilograms. So our axes are always straight lines, or somewhat straight lines, right? So our frequency looks like we're ranging from 2 to 11. So I'm going to go ahead and count by twos. 2, 4, 6, 8, 10, and 12. Now our weights, this is where the class mark comes into account, right? Because we don't really put intervals on our axis, right? We put numbers. So in this case, we're going to graph based on our class mark. So our first point is going to be 32. And now it's important to note that our class mark is of equal distance between one another, as graphs are, right? So 32, 37, 42, 47, 52, 57, and 62. Now, we simply graph based on our frequency. So at 32, we have 2. 37, we have 3. 42, we have 6. 47, 9. 52, 11. 57, 7. 62, 2. Now you might be thinking why I have lines. Well, because remember, it's an interval. We're actually graphing an interval, but for visual representation, we just have our mark, our class mark. Now, we connect in a bar graph form. Right, so it's covering the entire interval. Obviously, if you're doing questions on a test, you're going to have a ruler, and you'll be able to do nice straight lines. And that's it. This is our histogram. So you might get a question asking for frequency polygon. Now, what is a frequency polygon? Well, once we have a histogram, our frequency polygon is simply the middle of each bar, right? So essentially our class mark, connected in a line. So connected in a line. Now it's important to note that these lines are not going to be smooth symmetrical lines, right? Because our graph is not a smooth symmetrical graph. Right, so this here is our frequency polygon in blue. Now, this is useful, going back to our probability questions, if we're asked to determine the probability that a student picked at random would fall in the 42, 44 interval, right? So the frequency is 6, and our total, we would sum up to be 40. So our probability is 6 over 40. And that's it. That's all there is to graphical representation of raw data.